Welcome to the Slop Temple. We pray this video helps.
You begin by confirming models share consistent units and usable origins. This avoids misaligned mates later. Once done, create a working copy and suppress flexible parts so changes don't cascade. Make reference geometry now, planes, axes, and key faces that will act as datums. This preparation saves time because mates depend on predictable references. As you move into mating, use simple coincident or concentric mates, first to lock core degrees of freedom, before adding constraint. Now you apply core mate types and test motion as you go. Start with coincident and concentric mates on primary datums to remove translation and rotation where needed. Then add distance or angle mates for precise offsets. Make sure to avoid redundant mates by checking the degrees of freedom display. Redundant constraints cause solver errors. Use symmetric or width mates for balanced geometry, and organize mates into folders with clear names so you can isolate and edit problem areas quickly. Finish by stabilizing the assembly. Apply ground or lock mates to fixed components and use fixed references sparingly to avoid overconstraining. Once stable, run move component and enable collision detection to validate clearances. If mates fail or the model is overconstrained, suppress the newest mates, inspect dependent references, and reapply using alternate reference geometry. This isolates the conflict. One quick troubleshooting tip: toggle display of mate errors and degrees of freedom to pinpoint the offending mate before mass editing.
Thanks for watching. Consider subscribing if we helped you.